100 years ago, 37-year-old Albert Einstein overpassed the gravity theory of Newton's and apple fall to the ground. He published the general theory of relativity, which shocked the world, and explained some core regulations of the universe. General relativity believes that time and space is like a huge rubber membrane. On this membrane, if you put any object with huge mass, such as the Earth, this membrane will be compressed. That is, the surrounding space-time has been deformed, bending. Putting other huge object, such as the Sun, it deforms the space and time. The Earth will track along this curved time-space as its orbit. It also called the states as the Earth goes around the Sun. Based on this theory, he later proposed that this deformation caused by time-space, which is transmitted at the light speed in the universe, and after, he named it gravitational waves. But he regretted, this kind of deformation is too small. If humans want to measure, it is impossible. Because the power gravitational wave is such small, that even our solar system can only generate the gravitational wave power as much as an ordinary light bulb. For 100 years, Albert Einstein's general theory of relativity has almost passed every verification. Gravitational redshift, observed in 1959. Mercury's orbit eccentricity precession, observed in 1965. Gravitational lensing, observed in 1980. Therefore, the general relativity has been considered to be the theoretical model which closest to the truth of the universe. But this great theory is still waiting for the last piece of the puzzle, that is, Einstein's prophecy. Gravitational waves has not yet been observed by humans. The first observation of gravitational waves was made on September 14, 2015 and was announced by the LIGO. The two interferometers located in Washington State and Louisiana State simultaneously received a beautiful sound from deep universe. The experiment, which took 40 years and after nearly $1 billion, finally confirmed Einstein's predictions, and let the impossible measurement in his mouth become possible. Each gravitational wave observatory consists of two mutually perpendicular, 4 km vacuum pipes. As long as this time-space shackles arrive as predicted, the length of the object will change when it is swept. The change of the length of the tubes is sharply reflected in the path length of the laser in the tube, and finally causes the change of the interference pattern of the two laser beams. Further analysis confirmed that this wave signal originated at the merge of two massive black holes with beyond 1.3 billion light-years. According to the general theory of relativity we introduced earlier, in the process of merging, the rotation of two black holes caused a bending of space and time. This huge energy spread to the universe in the form of gravitational waves, and finally, after 1.3 billion years, arrived at the Earth. This discovery not only confirms once again the general theory of relativity, the greatest physical theory of mankind since the 20th century. More importantly, since then, human beings have learned about the world apart from relying on telescopes. What is even more exciting is that humans' further observations of the early universe have become possible. Prior to this, due to the fog state of the early universe, light could not bring enough information to humans. But with the gravitational wave, humans have broken through this barrier and have the opportunity to return to the initial moment of the Big Bang. 1.3 billion years before, animals in sea started evolving eyes to see the light. After 1.3 billion years, humans successfully opened ears to hear the background sound of universe. Undoubtedly, this research has important significance in the history of human scientific discoveries. I am Daniel Shaving. If you like, please subscribe my YouTube channel.